It is given in this problem that there is a wire having a resistance of 10 ohms. It is stretched by 1 by 10th of its length. What is the new resistance here? So what he is saying in the problem is there is a wire whose resistance is equal to length L. Now it is stretched in such a way that its length is increased by 1 by 10th of its length. That means the new length is L by 10. What's the new resistance? As the length changes, resistance also changes. How much is the new resistance is the question. We know the formula, if you remember, resistance is directly proportional to length and inversely proportional to area. So resistance is equal to proportionality constant, resistivity, rho, L by A. But if you look at the problem, there is no information about area. As wire expands, its length increases, simultaneously its area of cross section decreases. But we don't have any information about that area. So we'll eliminate that area and try to write that area also in terms of length using what? Density is equal to, I can put a formula, mass by volume. Mass by volume can be written like area into length. So instead of area, I can write mass by density into length. So that our new formula will be resistance R. This is equal to rho L, instead of area, mass by density into length. So if you rewrite all those terms, resistance R equal to rho L, this denominator of denominator becomes a numerator, density and length by M. So that is equal to rho L square density by mass. For a given resistance, rho always remains constant, density remains always constant, mass remains constant. That implies resistance of that wire is directly proportional to L square is the formula that we can derive. We can use this formula now to solve this problem. That implies R1 by R2 equal to L1 by L2 whole square. Be careful, as I have eliminated the term of the area, resistance instead of becoming directly proportional to length now became directly proportional to L square in that case. That implies, further I can write R1 by R2 is, L1 is L, L2 is L increased by L by 10, so L plus L by 10 whole square. That is L by L plus L by 10 is 0.1 times of L whole square. That is L by 1.1 times of L whole square. L and L can be cancelled. So if you rewrite the terms, R1 by R2 equal to L by, L is already got cancelled, 1 by 1.1 whole square. So if you reverse that, R2 by R1 is 1.1 whole square is 1.21 by 1. 1 square is 1 itself. That implies R2 is equal to 1.21 times of R1. It is given in the problem that R1 is 10 ohms. That implies R2 equal to 1.21 into 10. The new resistance after stretching by 10% of its length, 1 by 10th of its length is 12.1 ohms. That's the answer for the problem. So just to give you a conclusion, be careful to understand that this point, R2 is 1.21 times of R1 means R2 is greater than R1 by 0.21, or if I write that into percentage, 21%. This is how we can solve the problem. Thank you for watching. And if suppose the variation in the length is not this large, so if suppose I'm just handling a different problem just for the sake of clarity. If suppose somebody say, if length is increased by 2% of a wire, similar to that wire, what is New resistance is if somebody asks. R is directly proportional L to L square. As the increase is small, we have tried an approximation. Delta R by R is 2 into delta L by L. 2 into delta L by L is 2% as given in the problem. That is 4%. So increase in the length is 4% of original resistance. So this kind of problem when the percentage is small has to be handled slightly differently, just for the sake of your notice. That's it.